Hello Year 11 Mathematics Advanced students. Today we're continuing on with the topic of Introduction to Calculus, and we're going to learn about short methods of differentiation. So we're going to talk about the derivative of x to the power of n. So the gradient of the straight line y equals mxc is m. So if y equals mx, then the derivative, or f dash x equals dy on dx, will just equal m. So our derivative of our functions is just if we remember back to when we first started this topic, is just the gradient function. So what we have to remember is that when we sketch the graph of our gradient values, which we call y equals f dash x, the gradient function or the derivative function is this. Okay, so when we start off with our function f dash x, we then draw tangents to work out what our gradients are, and then we get these other functions which we call the derivative function. So we need to remember that our derivative function, when we have a parabola, it changes into a straight line. So we have that our value or our power decreases by 1. So we need to note that for dy on dx, or d on dx, which is our function f of x, or y dash, is a new way of writing f dash x. So we have the derivative of kx, which is when we differentiate, so d on dx of kx just equals k. So this is where k is constant. So this relates back up to if we had our gradient of our straight line. So that's when we have our straight line. So our horizontal line with the equation in the form of y equals k has a gradient of 0. So the reason it has a gradient of 0 is because we can't draw a tangent anywhere along these lines that isn't going to be 0. Oops, sorry. So then if y equals k, then dy on dx equals 0. So this is where our derivative constant of k is d on dx k equals 0, where k is a constant. We then have the derivative of x to the power of n. So the derivative of x to the power of n is going to be d on dx of x to the power of n equals n times x to the power of n minus 1, which is the same as equal to nx to the power of n minus 1. So this is where this n minus 1 comes into account when we have a parabola and we're finding the derivative function. We would have noticed from sketching a little while back that it is, when we sketch the derivative function of a parabola, it is a straight line. When we sketch the derivative function of a cubic, it is a parabola. So our power is decreasing by 1. So we bring our power out the front, multiply it to our x, and then decrease the power by 1. So the derivative of kx to the power of n is d on dx equals of kx to the power of n, k times nx to the power of n minus 1, which is knx to the power of n minus 1. And so this is just when we have a coefficient of our x squared. We then have the derivative of a constant multiple of a function. So that's when we have a function and it has a constant out the front of it. What we do is we need to just times the constant by the derivative of the function. So this is d on dx is k f of x, which equals k times the f dash x. So let's have a look at some examples. We want to find the derivative of 4x to the power of 6. So what we do is we're going to, this one is exactly like our, this example is an example of our derivatives of k x to the power of n. So what we have is we have our k equals 4 and our n equals 6. So it's d on dx of our 4x to the power of 6 equals our k of 4, so 4 times our n of 6 times x to the power of n minus 1, where our n is 6, so 6 minus 1. So this equals 4 times 6, which is 24. X to the power of 6 minus 1 is just 5. So that is our answer. If we were to differentiate fx equals 9x to the power of 5, this is the same as what we just did. So we have our k to be equal to 9, our n to equal 5. So we have d on, we actually have fx, so we're going to write f dash x equals our k, so our 9, oh sorry, yes, our 9 times our 5 times our x to the power of 5 minus 1. So f dash x will equal 9 times 5, which is 45. X to the power of 5 minus 1 is 4. And so we have differentiated f of x. Now we have the derivative of a sum and difference of functions. Oops, this box is gone a bit wild. So that's when we have the derivative of f of x plus or minus g of x equals the derivative of f of x plus or minus the derivative of g of x, so g dash x. So that's the derivative of sum and difference of functions. Now let's have a look at some examples. So we want to differentiate x squared plus x to the power of 8. So what we have to do here is we are adding them together. So we are simply going to find y dash. This is where y equals x squared plus x to the power of 8. So this is the same as derivative. So all we do is we bring our power of 2 out the front, and then we times it by x, and then we have 2 minus 1 at the top. Plus we bring our 8 out the front, x to the power of 8 minus 1. So then y dash will equal 2x, 2 minus 1 is just 1, plus 8x to the power of 7. Now we want to find the derivative of negative 5x. So we're going to let y equal negative 5x. So then y dash will equal negative 5. There's no power, so we're just going to times, so there'd be an imaginary power of 1 there. So if, so you can just go, so there's an imaginary power of 1 there. So we'd go negative 5 times 1, and then x to the power of 1 minus 1, which is negative 5 times 1 is just negative 5. And then x to the power of 1 minus 1 is just going to be x to the power of 0. So times x to the power of 0, where x to the power of 0 is just equal to 1. So then this is just 5 times 1, where 5 times 1 is just negative 5. Example 3, if fx equals x to the power of 4 minus x to the power of 3 plus 9, find f dash x. So that is f dash x equals, we bring our, for our x to the power of 4, we bring our 4 out the front, so it's 4x to the power of 4 minus 1, minus, bring our 3 out the front, so it's 3x to the power of 3 minus 1, and then this here is plus 9, and so it's our constant. So if we look back, the derivative of a constant is just 0. So that's going to cancel out to be a 0. So this is just going to be a 0. So it's just going to be plus 0. So then we have f dash x equals 4x to the power of 4 minus 1 is 3. Minus 3x to the power of 3 minus 1 is 2. And our plus 0 just disappears. Now we want to work out what is the derivative of y equals 2x to the power of 5. So we're finding y dash, so that equals, we bring our 5 out the front, times it by our 2, x to the power of 5 minus 1. So this is where our k was 5 and, no, sorry, our k was 2 and our n equals 5. It doesn't matter which order you write that in. As long as you're multiplying, you bring the 5 out the front and timesing it by the 2. So then this is y dash equals 5 times 2 is 10. X to the power of 5 minus 1 is 4. Now we have if fx equals 4x cubed minus 7x to the power of 6 plus 6x minus 1, we want to find the derivative of, or find f dash when we sub negative 1 in for x. So we first need to find the derivative, so f dash x. So we bring our 3 out the front, so it's 3 times 4, x to the power of 3 minus 1, minus 7, bring our 6 out the front, so it will be minus 6 times 7, x to the power of 6 minus 1, plus 6, x to the times, plus 6 times 1, x to the power of 1 minus 1, and then again our minus 1, it just cancels out to be 0, so it's plus 0. So then we have f dash x equals 12x squared minus 42x to the power of 5 plus 6, and a little reminder that our x to the power of 1 minus 1 is just equal to x to the power of 0, where x to the power of 0 equals 1. So then this is just 6 times 1, which is just 6. So now that we have that, we can sub negative 1 in for where we have x. So f dash negative 1 is 12 times negative 1 squared minus 42 times negative 1 to the power of 5 plus 6. And so when we sub that into our calculator, we get 12 times negative 1 to the power of 2 minus 42 times negative 1 to the power of 5 minus 42 times minus 1 to the power of 5 plus 6. So we get that equals 60. Example 6, we have find f dash x if fx equals 2x squared bracket 4x minus 3. So first we need to expand our brackets. So we want to expand our function. So we'll have fx equals 2 times 4 is 8. So this is where we're timesing our 2x squared into both items in our bracket. So it is 2 times 4 is 8, and we have 3 x's, so x cubed, minus 2 times 3 is 6x squared. So now we can differentiate. So f dash x will equal 3 times 8x to the power of 3 minus 1 minus 2 times 6x to the power of 2 minus 1. So this just equals 3 times 8 is 24x squared minus 12x. For example 7, we have find the derivative of 3x squared plus 5x all over 2x. So what we need to do for this one is we need to simplify first. So we want to simplify. So it will be 3x squared on 2x plus 5x on 2x, which then equals, we can cancel out some x's here. So it will be 3x on 2 plus 5 on 2. So we're going to find the derivative of that. So we can go d on dx of 3x on 2 plus 5 on 2, which equals, so 3x on 2, that's just got the 3 over 2 out the front of the x, and it would be x to the power of 1 minus 1, which is just going to be 0. And then because this is a constant, when we had constant, what colour did we do? Yellow. Because this is a constant, it just cancels out. So we have that as nothing. So the derivative is just 3 over 2. And finally, our last example is if p equals 8n squared plus 3n, we want to differentiate p with respect to n. So i.e. we find dp over dn. So dp over dn will equal 2 times our 8. So we brought our power of 2 down. N to the power of 2 minus 1 plus 3 times n to the power of 1 minus 1. So dp on dn equals 2 times 8 is 16 n plus 3, and this n to the power of n to the power of 1 minus 1 is just going to be n to the power of 0, so that will just cancel out to be 1. So 3 times 1 is just 3. So our answer is dp over dn equals 16n plus